All right, so welcome to my final presentation of my master thesis. So welcome to this Technasium class. I'm going to be your teacher for the coming 2 months. And I'm going to teach you about electronics and how you can use that in the real world and how you can build stuff with it and how you can understand how stuff around you works. If you just take a moment to look around you in this classroom, there's like computers on your tables, there is light in the ceiling, there's all types of technology that is used in our daily lives. And I think it's important that you understand how this works and how you can use it. So in this class, we're going to explore this and we're going to play with it as well. So it's going to be fun, I think, because we're going to use smartphones that you're all familiar with. And we're going to use that to explore how systems around us work and how we can use them to build stuff. Since we're using smartphones, don't use other apps than Arduino Action. If I see someone using social media, you have to take your phone and you'll get it back at the end of the class. So I think I can trust you all on this, and we need to trust each other so we can learn together. So today I'm gonna show you how Arduino Action works, how sensors and actuators in the real world work. Then after that, we're gonna experiment with sensors and actuators, and you're gonna record 3 different explorations. We're gonna sketch and record 3 ideas for the design brief, and then you're gonna present your idea and the process that you have for this design brief. So on the table that you have in front of you, you're already divided in groups. There's a laptop, and if you open the laptop and go to Arduino Action, which is on the desktop, and you click on that, then you come here. And if you then go to Add Phone in the left top corner, then you can choose, or you get a QR code and you can scan that with your phone, and then you're connected to this system. So today I'm going to show you how the documenter and the channel builder work. So if you open the app, then you can scroll through the different roles that you can be. And for today, we're going to use the channel builder and the documenter. So if you look at the channel definer and you press choose, then you can scroll through the different roles or the different types of inputs and outputs that you can use. And if you tap on the right arrow, you see a little explanation in terms of in a video that is explaining how the sensor or actuator works. So for example, if you go to the servos and you press on the right arrow, then you see a servo moving and you can understand what values it's using to move to that certain position. Also, if you tap on the white block that is showing the value, you can change the way you see the value. So you can make it a dial or you can make it a voltage, and you can understand things through different ways through that. When you choose the type, you also have to choose a port. So you do that in this way. So for today, we're going to use virtual ports. And if you press on done, then you get here. And this is showing the way you can control this channel. So you can then influence this channel by pressing the button. And you see the value changing in the white top, in the little block on the white top corner. In the documenter, you can use these values on your screen. So you can use them in your video to explain what is happening there. So everything is connected. So the system on the screen then shows this value. Your documenter tool shows this value, and the channel definer shows this value. And together you can then make a video of how things in the real world work. So some examples from last year. One group decided to go into the teacher kitchen, and they focused on the coffee machine and the blender. And they found out that in the blender, there's actually a button that is not being pressed by humans, but is being pressed by putting the thing on. So it's kind of a safety lock. So they found out how this works and how you can change it. So let's start. Remember to switch roles after each exercise. Always ask for permission to film, because you cannot just film people if they don't give you permission. And it's not about making a brilliant movie, but it's about showing the concept of how things work. So welcome back. Today we're going to experiment with sensors and actuators and record and build 3 different explorations. So for today we need the documenter tool, the channel definer tool, and the electronic builder. And again, remember to switch roles after each exercise. So let's explore the electronic builder. In the electronic builder, just like the other tools, you have different ways of seeing how it works. So you can have this photo, or you can have a schematic or iconic representation or a schematic representation. And that way you know how you should connect it, because you have seen the breadboard before in the electronics course. So you know a bit how electronics works, and this is like a way to apply it to the different types of inputs and outputs. So one group from last year, they made a sleeping sensor. So when your head is on the pillow, the sensor is being pressed, which is just a push button. But I think it was interesting because they just took a simple push button and put it into a different context, and then it can have a different value to it. And what they found out is that they couldn't change the Boolean value to be high when you're sleeping on the pillow. And that's something that we will explore later, how you can change that. So one output example, one group decided to make a controller for the window blinds. So the group that had the servos as a category, they made this system that could control the window blinds. And they could control it with the slider in the channel define. So let's start. Each group will get a category defined by me, and then you will explore how you can use this in different scenarios and different ways. So welcome back. Today, we're gonna fake 3 different scenarios for your final concept. And we're gonna use Wizard of Oz for that. So you now know how to build circuits, you know how to control outputs, you know how to read inputs. And we're gonna play the computer and let the user try some prototypes. So for this class, your group should record 3 different scenarios, and you're gonna act like the computer by using the channel definer. And we're gonna make an interactive puzzle for an escape room. There is a company here in Umeå that is making escape rooms, and they're really interested in your concept. So they will get these concepts, these little experiments that you did, and they will give you some feedback on it. And then afterwards, they will choose one group that they will actually build in an escape room. So let's start. So welcome back. Today we're going to program one idea and actually test it. So for this, we're using the logic definer, and the logic definer, just like all the other rules, have some little videos that explain how things work. So what the different functions are doing. So on the left side, you see the logic gate. So this is an OR gate. So when you press one value, the LED will go on, but also when you press them both. So if the one button is pressed or the other button is pressed, the LED will go on. On the right side, you see a statement. So it's like a mathematical description of making a statement. So if this value is higher than 500, then the LED will go on. So you have these little descriptions or little explanations in video and really short videos that help you to understand what these functions are. And when you then go into the function definer or the logic definer, you can then change the statement. You can change the actions that happen because of that statement. And you see this represented in the big screen on the laptop as well. And you can see directly how it would influence the channels below. So an example, one group decided to use a distance sensor in the ceiling that was controlling the lock of a door. So here on the right side, you see how it works. So if a value is below 800, then they use the hand as a variable, as a channel that is not really doing anything, but is helping the program understand what is happening. So when the hand is going from low to high, when it's rising, the lock will change to 90 degrees. And when it is going from high to low, then it's falling, and then the lock will go back to 0 degrees. And they chose to have an emergency button. So if the people in the escape room can't get out, the controller can then press a button and make sure that people can get out. So this was a little summary of how a classroom would look like if they would apply Arduino Action in a classroom scenario. And I will now go into the different lessons and what is happening and what is the reasoning behind it. So it starts by looking into the real world, and it starts really specific, and it goes more and more general over time. So you start with specific things in the real world that are already existing. Then you start building specific experiments. Then you're gonna play out a specific scenario, and then you're gonna generalize from this specific scenario what are the logic rules that are happening in that scenario. So it starts by looking into the real world and connecting this channel definer to a video without building any hardware or starting with electronics. So it's all about understanding the real world and communicating that for other students and for yourself as well. And then it's about experimenting with sensors and actuators. So here you start building electronics and you start exploring electronics without doing programming yet. You just start exploring how it works and how you can use it in scenarios. Then you play out the scenario using Wizard of Oz, where you might have multiple inputs or multiple outputs, and you just fake the logic at that moment. And then in lesson 4, you combine everything. So you add the logic to these fake scenarios and you can make them real. And you understand these logic, not through reading, but through seeing what this logic actually would do in a real scenario. So I try to make these videos in such a way that you can really understand what is happening without having to read about it. It's more about understanding by seeing. So Arduino Action is a collaborative tool for understanding that can also define logic, which is kind of different from how normally people build programming tools, where it's about programming, and then there might be a different platform or some features in the programming environment that help understanding. But the core is now to start from understanding and then add the logic later on. So for example, with CTC Go, which is a product that is out there from Arduino, there is sort of the difference between the platform that is made for understanding, the content platform, and the Arduino IDE. And these are a bit disconnected in a way that the IDE is not really made for education per se. There's more like a programming environment, and the documentation on the platform is not really interactive as the hardware would be. So I think this disconnect is interesting to sort of bridge and to make tools that start from understanding and then go to programming. So Arduino Action is a bit like a wing mirror. It makes you see more, understand the situation from different angles, through different representations. It gives you confidence to explore because you know what is happening behind the scene. And it helps you to become a good social driver because you can show other people how something works, including the teacher sometimes, because the teacher also has a hard time to understand what is wrong if the teacher didn't build it himself or herself. So it's really important to sort of give these hints and this visual information so people can actually jump onto the project quite easily. As Brad Victor said, people understand what they can see. If a programmer cannot see what a program is doing, she can't understand it. And I think this is really important and really crucial, especially when you're starting to learn Arduino, because a lot of stuff is happening invisibly in the code. And the only thing you see is what the outputs are doing. And if something happens in between, you don't really understand what is happening. So I focused on video because it's super contextual. You can directly understand the context. And because this on-top information that shows you what is happening behind the hood. Things like YouTube and TikTok and other social platforms are super popular among students. And this might also help them to get motivation to make these videos and start learning about this. And it creates good presentation material that they can share with older students, or that is shared from older students with the students. So they know that their input is being valued and being used. So I visited different schools and also design-based learning classes, which is this technasium that I was talking about. And the main goals are to make students curious. And in the design of this tool, I deliberately added information and interactions that can trigger curiosity. So these swiping interactions are quite enjoyable and they make you curious what more there is, what different categories there are. And these super short boomerang type of videos explain difficult concepts in seconds. So you can really easily explore what something is or explore what something would look like in different scenarios. The focus is on the context. The tools are just tools to make it work, to make you understand the context. So it's not about learning Arduino per se, it's more about using Arduino to learn about the real world. And it's about making programming collaborative, because the tools right now are not really supporting collaborative work. You're usually behind your laptop programming as an individual, and this would sort of open up multiple people to interact at the same time. And you would see that, for example, with when you're faking a scenario, you need a wizard, you need a documenter, you need a user, and all together you're building this concept. So a bit of my process, I focused on what people say, how people act, and how people envision the future. So for this, I went on a field trip to the Netherlands to visit different schools, both quite structured schools where there was technology taught or science, and also more design-based classes where it was more about the creativity and building a scenario. What one student said in the technology class was quite something that stuck with me, is we don't learn that much from copying code. If I'm here anyway, I better learn anything. And yeah, he was a bit of a rebellious guy, I think, but I think he sort of touched the core of, he didn't feel the ownership of owning the project or owning what he was doing. But I chose to go for the more design-based learning direction, because Arduino and physical computing are usually promoted as tools for this, but the current tools aren't really supporting this way of thinking or prototyping. It's really about defining the logic and understanding computing, and it's actually a better tool right now to learn in technology class and learn computational thinking than to learn design-based learning. So this would have a different angle and would create a different product within the in the different products that they make. So I did interviews with different teachers, trainers, so trainers, people that train teachers to become Arduino teacher, and experts in the field of education. And also one artist that is on the top right, which I quite like. He was using dance to program a website. And I think using these different ways of thinking about programming doesn't have to be on a keyboard. Programming doesn't have to be boring and text. It's quite interesting. And I think, yeah, it really helped me to sort of break out of this mindset of how coding looks today and how we can use it differently. I did a workshop with Arduino Education as well. So Arduino is in Italy. Arduino Education is a part of that, and it's in Malmo. So I've been there, and we explored. So I shared the insights from my field trip. We were acting out scenarios from the field trip that I saw, and then we were ideating based on these scenarios on how we might change the way these tools work. So we clustered the insights from my work or from my research together with their own insights. So I asked them to bring post-its with like little descriptions of what they think should improve in Arduino and what is really one of the core values. And I clustered these out into different categories, or we clustered them out. So right now, programming is a prerequisite for starting to explore. But in Arduino Action, I'm trying to start with exploring, and then programming can come later. There's lack of teamwork while using Arduino, and teamwork is now the foundation of the tool. There's lots of different components. I think there might still be lots of different components, but if you have a clear overview of which category they fall in and how you can use them using these little videos, it might help you understand what is happening. Instability is something that is more a technical issue, so I didn't really get deeper into that. And you have to learn 3 things at the same time. And I think Arduino Action kind of helps to scaffold this understanding. So you use first not even electronics to understand the world around you, and then you start using electronics, and then you start using programming. So you scaffold your understanding throughout the journey. So the idea is to focus on real tools, also used outside of the school, to focus on the ownership. So how can you make students feel that they own the project that they're making? And how can you share this philosophy of Arduino about sharing and community, and that there's no limits to what is possible. And I think I try to stick to these values as well. Then I've been reading into social research, social learning research, programming research, learning programming research, and interaction design, and how that sort of blends into programming as well. So I think one interesting paper is where they compared programming through blocks and text, and they asked the students afterwards if programming is hard. And the students with the block-based language would answer yes, because what they see in front of them, they didn't think that that was programming. So I think there is some kind of box where programming is put in, which is like a text-based representation where we can actually break out of. But because our social construct is that programming looks hard and looks like text, it's really hard. As Edgar Dijkstra said as well, the tools we use have a profound influence on our thinking habits and therefore on our thinking abilities. I think this is really important and crucial to highlight that the tools that we use really influence the way we think about what is possible. I've been looking into active reading or active learning, and I think this is really important. If there is one thing from this lecture or presentation that you should take out of it, then it is that if you just take 2 minutes every 15 minutes in a class and just have the students discuss with each other, their results on the content are insanely improved. So I didn't expect this. I would like expect 10% better in performance or whatever. But if you look at this chart, it's like 80% versus 20%, which is like insane. So just breaking the class up to little snippets and having students discuss in between already changes a lot on how people understand things. And if you look at, for example, my technical university where I did my bachelor, there are still a lot of courses that are just being taught like 15 minutes long lectures. So yeah, and this is known from the 1980s. This is not new. The myth on learning styles. So I don't know if you have seen these diagrams in the past, but the idea that people are auditory learners or visual learners is not true. It is just the case that some content is better being taught by visual explanations and some content is better through auditory representations. It's more about the content and people's knowledge before than it is about people having a learning style. But it's good to have diverse ways of representing things because you have different angles to understand it. Why I chose to use the timeline in my final concept is because I saw teachers using this when they were helping students. They would write down a little timeline and make students understand, and it would actually really help the students to understand what was happening. And also this Arduino added this serial plotter in their IDE, and that was mentioned by teachers as well as a really valuable way to do demonstrations in front of the class, for example. So I think the timeline is really a nice way to understand things. This is some work done by Brett Victor, and I think it's really interesting. So he focused on showing the steps in a program, focused on direct manipulation. So how can you directly see what you're doing has an influence, and how can you dump the parts on the floor, and how can you represent these in the way they actually belong to be represented instead of in text. The limitations of this is that it's still really UI defined, like it's really graphical because it is used in a graphical interface. Also, he focused on sort of rephrasing how weird our programming language looks like by putting it in a UX and by showing that it's really important to have different ways of seeing something. So you understand from different angles and different complexities on different levels. So the scope of this project is to sort of bridge this gap from tools for analyzing hardware and tools that enhance understanding, and focus on tools that can create behavior, but also help you analyze it. I focused on making more social tools instead of individual tools because Arduino was taught in groups in all my observations, and there is a tendency to have one designated coder during this group work, and time pressure makes people take their preferred role, and current tools are made for individual use. So I think we should change the tools so they actually allow for this group work and collaboration. Make it more fluid as well. So if you would map it out, then you have individual, social, fluid, and rigid. And I first tried to explore what fluid code would look like. So I did some different experiments where you would use, for example, the cursor on the left side. You would use the cursor, and the cursor would then define the color of the LED or the movement of a servo. And this is a different way to think about code. Behavior doesn't have to be described in text, right? It's just code is described in text, but also that is defining behavior. So we can think differently about this. And in the middle, you have this Photoshop view, and in Photoshop you can then define the behavior by using gradients and using paint tools to define how the behavior would look like. On the right side, you have Keynote to Arduino, where you use a tool that is actually made for communication to also do the behavior for the Arduino. So again, the documentation comes first, and then the behavior is an addition to the documentation. So these tools are a bit more in the fluid end of the spectrum. They're not necessarily more social, some are more visible, so it's easier to share and understand together, but they are still mainly focused on individual interfaces. Then I focused on Arduino teams, which is the idea that you would have different roles and you would have to switch through the role each time. So you would have a documenter, a function chooser, and an argument chooser, and these have to work together to make the code happen. This is a bit more social, but it's also as rigid as it is today, because I didn't change the way code works or the way people interact is changed, but not really the way code works or the rigid nature of it. Then I also experimented to think differently about debugging, using sound, using a phone that would show what the Arduino is seeing, using a timeline that would show what the program is doing, together with video as well, and using this thing from Bad Victor where you would see the line that is being executed right now. And I think these all help to understand, to scaffold this understanding of what is happening at a certain moment. Yeah, again, I think these are somewhere in the middle. I think the board view was quite interesting also because of the sound. So the whole group knows what the program is doing at a certain point, because it's not just visual on one interface, it becomes sound as well. So then multiple people can understand if I press the button and the sound doesn't work, then there's something wrong with the cable in between, for example. I also focused on metaphors to think differently about programming. One I think is quite interesting is this painting metaphor. So with paint, we have like a way to white the wall, and we have one that is more about making art. And I don't know if we really have programming that is focused on this more art side of things. What would that look like if we don't use it to paint a wall? And I think most tools are now focused on efficiency and just getting tasks done, which is something different than making art. Focused on team sport and music. Music I think is also interesting because it's about exploring what the instrument can do, exploring it together in a symphony, and then write down what worked together to make it transferable. Focused on different media. So this tablet or the laptop, the tabletop projection, I think is quite interesting, but it's just not really feasible to ask schools to put a projector on top of every table. I think in terms of interaction, it could be really nice because you can see contextual on the board what is happening. And the smartphone is quite nice, I think, because it's really cheap, it's already there, and you can carry it around. It's really portable, and it creates, in that sense, everyone can have their own smartphone, so you can have different roles. You can switch through these roles quite easily. So Arduino Action tries to be somewhere in the fluid social realm of things. In terms of visual style, I wanted to make it real, so show real hardware, not like some abstract representation of hardware, but show the real thing. Make simple and colorful visuals and make it kind of familiar. So I'm using a bit of Google material design, some metaphors from Instagram and other social networks. So you start to, it's kind of familiar, but it's still, it looks quite fresh in a way. So these are all the parts of it again. So the logic builder, the electronic builder, the documenter, and the channel definer. And these all work together in a symphony with this bigger screen that is then representing how everything comes together and where people are. So you can see that Kira is now documenting and Lisa is doing the logic. And you can see how these channels are influencing each other. So programming is a canvas that is too big to paint as an individual. So why do the tools still make it an individual sport? Thanks. And special thanks to Sebastian from Arduino, who helped me and tutored me throughout the process. Ilva, my mentor from KTH, and students and teachers that I visited throughout the process, and the experts as well, and of course our lovely class, IXD Massive. Thanks.
Woo.
Nice presentation. I felt like back in school. Very nice.
That was the goal.
Not sure if I learned much. There was no social learning going on. No. Nice presentation. A very interesting project to take a completely different tack on what, like tack is in turn on what programming can be like. Can I start with a question? Or my first question would be a term that came up that I need some definition of. So what is design-based learning?
So the idea is that the focus is on how you iterate with technology. So in the context that I was and visited the school, they use it in a specific context. So they would use it together with a company that is close by the school. And then they would do a little design brief for that company or that environment. And they would, the focus in the class that I visited was on this escape room. So how to build an escape room and how to make, so there was a specific focus on you have to build something with Arduino in that escape room. So you had to go through the struggle of making something electronical. But in that sense, they learn it in a context and it's different from normally technology education, where it's more about computational thinking, where you just focus on learning programming.
So is it project-based learning?
Yeah.
Okay. And so you're using that as one of your main inspirations on the platform you're creating, or the learning tools that you're creating.
Yeah.
Yeah. Cool. So one of the sort of core values you're working with is this collaborative learning. Is that just for the learning, or do you also envision programming at later stages, like when you get more proficient, as a collaborative activity?
Yeah, hopefully. So I have a slide on this, but I don't know. I think that the idea is that normally education just uses tools from industry, but I think education should also force industry to change in a way. So there's more like education-led innovation, where it's about understanding first and then doing programming, which will help the general public, but also help future programmers to understand what they're doing.
Right. Right. You say something interesting. So coding is just a way of defining behavior, but there are many other ways to define behavior. And at the end of your presentation, you also show some of these examples. Maybe conveniently, quite a few of these behaviors are quite simple. So how does your approach, or have you no, so you're opening up sort of a view into a field of defining behavior differently. I wonder what that looks like when it becomes more complex behavior.
Yeah.
Do you have an idea of that, or
Me too.
Image that I can work with?
I'm really curious how that would look as well. I did try to sort of push this tool a little bit for that, but the main focus of this tool is not on making a programming IDE that can do everything that we want to do. It's more about starting from understanding. So this tool is a vision where you start from understanding and then add logic. And I think that's the core of this project, more than that has to be a tool that can do everything, because then you start opening up Pandora's box, which could be a thesis in itself, where I also sort of felt a bit lost. So does this need to do everything? I don't think it can do everything, but perhaps there could be ways, just like these parasites that I built, these experiments that use other tools to do something else. Perhaps this could also bridge to other tools, or could be a stepping stone into something else as well.
Yeah. So so you just made a statement about what it is you made. It's something that starts from understanding and then adds the digital layer, like at a later stage, or the abstraction level. So what is this teaching?
So it's teaching what sensors are, what actuators are, how you can use them, how you can control them, how they can work in a scenario, how they work in the context of the real world, how you can build contexts that are real world, that are in the real world. So it's teaching a lot about the essence of what using electronics and devices is, which is on how you interact with it and how it works and how it's connected. And it's indeed less about making a full programming IDE that can do everything. So yeah, this slide is sort of explaining it. It's like a collaborative tool for understanding that can also define logic. While most of the tools right now, they define logic and they also have some parts for understanding, but they don't really put it on the same level.
Yeah. And then one last question to sort of end this line of questioning. Why is that important?
Why is it important that you understand how things around you work? If not, we're just being passive consumers of this world around us, right? If we don't educate people to understand how the world around us works, how can they change it? How can they become the citizens that change the world?
So that's what's important.
Yeah. That's why I started with, right?
Remind me.
Yeah. Why are we learning this? If you look around you, you see so much technology.
But that is in the context of the course. So I'm trying to ask this in the context of the world. Why is this important?
But it is important.
Just because?
No, I just described it, right? If we don't understand how things around us work, how can we change the world? How can we have students that become citizens of this world that is full of technology and not understand what is happening around them? They need to understand.
Everybody has to become able to change the electronic systems around us.
Yeah, at least understand how it works.
But I don't need to understand combustion to drive a car.
But it would be nice to understand combustion.
Well,
no, I get your point. But I think, it is important to understand some part of it. And indeed, you don't have to understand everything about how a servo internally works. You don't have to understand everything about programming. But just this experience that you have in the classroom, that you can change the world around you, that you can actually build with the building blocks of technology, makes you aware that you can change. It gives you values that you can use the rest of your life. That makes you understand that you are able to change something and not just be a passive consumer of this world.
Now that answer has a scope that I can agree with. I mean, if it's about teaching or sort of giving this basic sense of agency, that I can have influence on the world, sure. But to say that everybody needs to become a, let's say, programmer, but then with different tools, or a behavior definer, I'm not so sure if that is so. I mean, I don't see that argument as strong.
Yeah, perhaps this class is also not being taught to everyone, right?
Right, exactly. So, sorry, I take a lot of time here again. Diana, do you want to have your line of questioning here?
Yeah, thank you. Great presentation. I really enjoyed it. The beginning was just, it captured us. Really nice. So I have a couple of questions. The first one, so you talked at some point about this sort of painting metaphor the painting of the wall or the sort of artistic painting. And I wonder, in your final result, what would you say, or is there a way to leave a trace for each of the people that are in the team, each of the, either the team members or in the roles that they take? Can they leave a trace of how they do things themselves? Is there any kind of documented art part of it in how they develop their project?
You mean showing the process?
Could be the process or in the result or their style or...
Yeah, I think the process becomes clearer than normally because you have different documentations that you made over time, right? I don't know if the roles are really, like, right now they're showing live on the screen, so you see where people are, basically what role they're taking. Might be that this is also documented over time, but I also don't want to confuse the interface too much with like historical information together with new information, and then it becomes like a mess. But I think that having these documentations of your process really can show the exploration process, and where you, yeah, it sort of forces this idea of documentation and sharing the process as well. If that's what you're asking.
Yeah, that's a good answer. Thank you. The other one, so you said something about using Arduino to learn about the real world, and that now in the discussion with Stoffel also that has been a big argument. And I wonder, how do you use the space, so not just the objects and the, you know, the objects with the artifacts within the Arduino system, but beyond that, how do you use the room, for example? How is that captured in the learning if we're learning about the world around us? So anything of a bigger scale, the building, the walls, the neighborhood, could you, or did you think of how to integrate that in this concept?
Yeah, so it's mostly in the curriculum that I showed right now, which is something that, of course, the teacher can fill in themselves. But by putting them out in the real world and looking for real world examples of digital inputs, digital outputs, they sort of connect this mythical world or this weird word of digital input to some real stuff in the real life. So that's one way how I tried to do it. I think it has to do with how you present this as well. So it's also really up to the teacher to make this connection to the reality clear and make sure that you force this curriculum to go into contextual directions. But the video shows the context. It's already more contextual than just having code, right?
Yep, thank you. The last question. You talked at the beginning in presenting the concept that they can change roles. So normally we can get a little lazy and maybe stay in the comfort zone and sort of go on with the role that we normally take. So you've introduced a way to change roles, and it's very clear, very explicit. But then when you were doing the presentation, as in acting to be a teacher, you kept telling us students, like, don't forget to change roles, don't forget to change roles. So I wonder, is that the way it's going to happen, or is there something in the design that is, you know, without a teacher telling me that I should know that I should change roles?
Yeah, so in this Arduino Teams concept, it would be super explicit. It would be like forced to change the role after every line you write. Yeah, this is something to try out as well. I don't know if it would make sense to really have the app change the interface suddenly when you recorded a video, if that would confuse a lot, or if that would help them to sort of know that they have to change the roles. There could also be some way for the teacher perhaps to monitor which roles people took over time, because you have of course you can take someone else's smartphone and do it, but I think you can see quite easily as a teacher then who recorded it and who was the user and who was. So that might also be a way for the teacher to sort of nudge this behavior of role changing. Just becomes the roles become more clear in the process.
Great, thank you.
You're welcome.
Unmute. I think that is the question time we have. Thank you for good answers, Geert. Of course, I try to push you a little bit.
Yeah, yeah,
I
yeah.
hope you're not too frustrated about that. But now Diana and I will meet in the breakout room, and then in about 10 minutes we'll be back.
Nice. Cool.